Good morning, and welcome to the webinar to introduce the PCO-7121. I'm Steve Krause, General Manager with IXIS Colorado, and I'm joined today by James Budai.
I'm the R&D engineer on this product.
And we're very happy to have you guys this morning. We're excited to talk to you about this new product. There are a few housekeeping items I need to go through before we get started. The first one is that I want to make sure everybody knows that this webinar will be recorded. The second is there are three functions in the webinar software that you should be aware of. On the lower left, there is a chat function. In the center, there's a raise your hand function. And then on the right, there is a question and answer function. And we'll be using those throughout the webinar this morning. So the first thing we want to do is if you can hear the audio and see the video, please let us know in the chat. And that's what we'll be using the chat function for, is immediate feedback, things that need to get taken care of. If the audio is not loud enough, if the video is not streaming correctly, please let us know in the chat and go ahead and hit that raise your hand button. And that provides us an immediate notification that something needs to be attended to. So next after that, we will be taking questions. If you have a question immediately, if you came to this webinar with a specific question in mind about the PCO-7121 or laser diode driver modules in general, please go ahead and feel free to enter those into the Q&A section anytime you want. We'll definitely be dedicating some time at the end of the presentation this morning to take care of those. But if you already know a question that you want to get answered, please go ahead and put that in. And we'll make sure and get those things answered when we get to the end of the program. We understand that some questions might require you to discuss intellectual property or might have a comprehensive environment that you need to talk about or a complex situation that isn't appropriate for putting into a text box on the screen. We understand that completely. Please feel free to email us at sales@directedenergy.com. And we'll connect with you individually to take care of those questions. And last, before we get started, if there's anything we can do to make these webinars more effective for you, make them a better use of your time, please feel free to let us know through email or phone call, whatever you'd like, and we will take that feedback. We really appreciate it. So let's start. What are we going to talk about today? The first thing we're going to do is go through an introductory video that will have a product overview. Then it will talk about what's in the box. What do you get when you order a PCO-7121? What accessories are available? What replacement parts are available? We'll talk about a technical overview. We'll talk about setting up the unit. And then we'll discuss solutions to common problems. At that point, the pre-recorded video will be over, and I will come back and we'll talk about price and availability. We'll also go through the Lab to Launch program, which I always like to introduce to people during these webinars. And then finally, we'll get to the Q&A section where we will answer any questions you might have about the PCO-7121 or anything else we've covered this morning. So without further ado, let's go ahead and watch that video. The PCO-7121 laser diode driver module provides from 5 to 50 amps of pulsed current at frequencies up to 1 megahertz and compliance voltages up to 5 volts. With an expansive range of current, voltage, and frequency combinations, this versatile module is ideal for a wide range of OEM applications. LIDAR, when more specific requirements exist, the PCO-7121 can be the perfect starting point for a unique solution.
Hello, my name is James Budai. In the photo here, we have the module itself corner, the control cable, and the manual. You can order extra control cables at any time using that DEI part number that's listed. Here is the top view of the board with the mechanical dimensions so you can design it into your OEM product. This module was designed to support many different laser diode packages. It supports the TO18, TO5, TO52, 5.6 millimeter and 9 millimeter diodes. And you could solder either this optional strip line or laser right on the edge of the board where you see a rectangular pad. There's also a rectangular pad on the rear side of the board that you can put the positive and negative leads. So what does the 7121 do for you? The 7121 has an output current that varies from 5 amps to 50 amps. The user controls that with an external voltage source that's adjustable from 5 volts to 95 volts. That voltage is on pins 5 and 6 of J1. The output pulse widths are controlled with your external trigger source. You can either drive the SMB connector or J1 pin 1 and 2. When the system is operating, you can expect a 12 nanosecond rise time and a 10 nanosecond fall time. And the module is RoHS compliant. Here's a graph showing the typical high voltage settings versus current. So these are a starting place for when you first power up the instrument, and after it warms up, the current will stabilize and it will drop a bit for about the first 10 minutes, and then it will stabilize, and then you will have to increase the voltage slightly to get to your operating current. Here is a safe operating area. So you want to make sure that you're always operating the module below these lines. This slide is the same graph, and I just wanted to go through a quick example. So let's say you were going to drive 50 amps to a laser diode, and you wanted a pulse width of 200 nanoseconds. So if you're wondering, how fast can I operate this at? So you follow the x-axis at 200 nanoseconds, follow that up, and then see where it intersects the graph, which is a lower graph, and we go across to the y-axis, which is on a log scale, and see our frequency is about 12 kilohertz is where you can operate that. So setting up the instrument. So when you receive it, you'll receive it in a box. The module itself is in an ESD box. It has a control cable and a manual. There is an option to order IMON cable or a stripline cable, and you'll be able to see what those part numbers are in the data sheet. So connecting up the instrument. So J1 has all our control signals. Everything's color coded. So if you notice, red goes to where it's showing the trigger on the silk screen of the board. Orange is going to where it says positive 15, and blue is going to the high voltage. So we'll see those connected in the next slide. J2 is the optional current monitor. So we connect the red and black wire to our trigger source, the orange and black wire to our voltage source, and the blue and black wire to our high voltage source. So when you put all that together, you enable your voltage supplies and you enable your trigger source. Then here is the output looking at it with an IMON. I should note that you must have a load. You must have either a laser or a shorted load to be able to get any current out of the module. So you need to make sure you attach those before you try to operate it. Otherwise, you're just not going to have any current coming out. So what are some typical problems and solutions? If you don't have any output pulse, what could it be? Well, first off, you need to make sure your trigger source can drive a 50 ohm load. You can't just drive this with regular digital logic. It needs to be able to drive a 50 ohm load. Also assure the 15 volt and the high voltage are both present, and make sure there is a load installed and soldered into place. Another typical problem is what if the output current is lower than you expect. First off, make sure you're operating within the safe operating area graph. So recheck your operating point and make sure you're underneath those lines. And you might have to increase your voltage slightly because the system's warmed up a little bit. And so after 10 or 15 minutes, everything stabilizes temperature-wise, and you shouldn't have to adjust the voltage anymore after that. And one of the other problems is ringing on the output. You really need to assure that the laser is soldered directly to the printed circuit boards with the leads as short as possible. We're trying to eliminate any parasitic inductance. If that doesn't help, then what you're going to have to do is reduce your output drive current because your laser might have too much parasitic inductance in the package, and you might not be able to get to the current level you would like.
The PCO-7121 is a powerful, flexible, affordable laser diode driver module that can jumpstart your design process and meet your OEM integration needs in manufacturing. Contact Directed Energy and find out how we can help you from lab to launch. Well, that wraps up the video. If you missed something or there's something you want to review on that particular video will be posted to the product website later this afternoon. So it'll be available, so you can scrub through it and take a look at any part that maybe you wanted to see again or wanted to review or share with a colleague. So let's get on to pricing and availability. The manufacturer's suggested retail price of the PCO-7121 is $397 in low quantities. And that's US pricing. Outside the United States, of course, there are factors that may affect the landed cost that you might see. Availability, we have a few in stock, and we have stock in the next few weeks. So we should be able to supply quantities very soon. Now I'd like to talk about the Lab to Launch program. This is a program that I really like to introduce when we have these webinars, because it allows us to partner with our customers one-on-one. We usually enter into an NDA so that we can be free to talk to each other and really get to know your product and your company. And we will help you design a pulse solution that's specific to what you need. So imagine, if you will, you've got a project that you've decided, okay, we want to go to market with a laser product that does a certain thing. And we need a pulse to do that, but we're not exactly sure what kind of pulse we want. So in that case, you might need something that has a wide variety of pulse characteristics, like 6425, which is shown here. And as you go through your development process, you're going to come up with what specific pulses are going to make your application successful. And at that point, you're going to want an OEM module that will go into your final product, so you don't have to worry about creating the pulse, but you have the performance that you need. And so when you get done, you might not want to put a 6425 or a PCX7500 or another large instrument into your final product, but you might need a smaller module product. And that's where we go with the OEM modules. And so we have a couple of options available. Obviously, we have the PCO-7121 seen here, or you have the PIM Mini, which is a fully enclosed module in case you need something that has a full enclosure. Both of them can be easily mounted to another chassis using the mounting holes that are provided. And so those options are available for you as we go through the project. And now you have, like I said, designed by experts in pulsing. These are manufactured in an ISO registered facility. They're tested and they're installed. They're tested and ready for installation in your unit. It saves you design time. Usually it saves development cost, and you don't have to worry about building the pulse module and testing it. So we like to get with customers as early as possible with Lab to Launch so that we can help minimize the cost of development of that part of your project. It allows you to focus on your core product and your core customer while we provide the solution for pulsing high current or high voltage. So at this point, we'd like to go ahead and move to the question and answer session. If you have a question already, please put it into the Q&A session, and we'll go ahead and answer it. This takes a little bit of time, so if we're quiet, we're still here, and we look forward to hearing any questions you might have.
Yes, so the question is, can one control the frequency programmatically? Well, you use an external trigger source, so it depends on what your trigger source is, but you fully control that. The next question is this for a CO2 laser. No, it's not for a CO2 laser. This is really for a laser diode. The next question, what is the frequency range for the trigger in? It goes to 1 megahertz. Could we pull up the data sheet or the presentation and look at the SOA curves again? And then we could point out maybe some examples. That's going to take us a second to pull that up. So while we're looking for it and trying to pull it up, you have to look. Let's go down to the second page, or it might be the third page. And I think everyone is seeing this. Hopefully, yep. Keep going down one more. So the frequency range really depends on your current. So if you look at these curves here, scroll down just a little bit more. So what we see on the x-axis is what your actual output pulse width is. So based off your actual pulse width and your current, you actually use the y-axis to determine what your maximum operating frequency is. Let me know if that answers your question, but you have to refer to this graph to determine what your maximum frequency is based off your pulse. Okay, it looks like we answered that question. Great. So yes, we did extensive testing of this module, and we feel the most comfortable to only operate this up to 35 degrees C.
I guess I would throw in the question, do you have a specific operating temperature in mind above 35 degrees C that you're interested in? Because the specification for the standard module is based on a wide range of use. If there's a specific application where you have a temperature in mind or a set of environmental requirements, let us know, and we can certainly talk to you about it. We want to be very respectful of everybody's time. And so if you're typing a question or you have a question, hit the raise hand button. And that way we'll know that a question is coming. But it looks like there's a couple questions coming up.
Okay, so we have a question. What is the heat sink requirements like? Well, if you operate the instrument in the safe operating area, which you should, you do not require to mount it on anything that cools it. So we have a heat spreader on there now, and it's been characterized with no airflow and with so you don't have to worry about the heat sink.
So I'll just bring this up. You can see that it's got a heat spreader here, and this is now if you do need to mount it, we do have the mounting holes, but it's got a very nice heat spreader, so it's not required. It's not dependent on other things.
What are the main users for this product? You want to answer that?
Sure. The product was generally designed for imaging and LIDAR applications, but this one has a pretty wide variety of operating conditions, so you're able to use it in maybe laboratory or other applications. So that's that. But like I said, basically the primary applications are LIDAR and imaging.
So we have another question. Can I go with HV until 100 volts? I believe we're rated at 95 volts. So the 95 volts is the maximum voltage.
I guess I would encourage you to, if there's a 100-volt application that you're looking at, contact us directly and we'd be happy to talk to you about it. So if you're typing a question right now, go ahead and hit the raise hand button so we know that there's somebody coming up. Oh, okay, I can answer this one. The data sheet and the operating manual are both already available on the website. Those are the website page for this product is live. So if you go to directedenergy.com, go to laser diode drivers and put 7121 in the little search box, it'll come right up. In fact, you can put 7121 in the homepage search box and it'll come right up. The data sheet, the manual are both available, and also this video, not the webinar video, but the video we showed earlier will also be available for review.
So we have another question. Could we overpass the maximum duration of 1,000 nanoseconds? No, you shouldn't. We have it specified for a maximum of 1 microsecond pulse width, but as Steve keeps mentioning, if we have a particular application, we could design it to do any pulse width that you need. So let us know if you have a specific application, and we would design a different module.
Can you talk a little bit about what the limitations are that are constraining that pulse width?
It's mostly thermal, and we characterized it there. So we fully characterized it there. We might be able to go a little bit higher, but we never characterized it. We don't want to recommend people operating outside those environments.
Oh, absolutely.
So how does this compare to the previous product from you? Good question. So let's see.
Well, with the previous product, so for example, if you're referring to the PCO-7121, which this product replaces, if you're familiar with that product, it's pretty much an identical replacement. The reason that we actually had to discontinue the 7120 was based on parts availability, and we simply couldn't get one of the key components anymore, and we had to design around that and put out a new product. But it's basically identical to that. It does have a better heat sink. There are the other thing you'll notice if you're familiar with that product is James was able to design a much more economical board. In this iteration, we were able to design out a lot of cost. And if you're talking about, maybe you're thinking of the PCO-7110 series or 7810 series, where we have fixed pulse widths. The difference here is that you've got a module with variable pulse width so that you can do a lot more experimentation or have a wider range of operating characteristics.
And I'd like to add, I think, a little bit too. So the module is slightly larger than the 7120. It's not a direct bolt-in, and it has a slightly different electronic interface with the control cable. And the minimum pulse width is a little bit wider on this module due to a part going obsolete that we can no longer make. But other than that, it is the pulse width. The pulse width range on this is approximately, I believe, 22 nanoseconds to 1,000 nanoseconds. And I believe the previous one was 12 nanoseconds to 1,000 nanoseconds.
So, another question.
And I just covered that.
Nope.
Oh, on the left. at 65 degrees Celsius environment, can I use a big heat sink? You'd have to really cool it down to be able to operate it at 65 degrees. Please contact us before your application. If we need to design something to run significantly hotter, we can definitely do that. The next question, is it possible to repair in case of overcurrent or over voltage fault? It should be, right? That's up to the factory here. No one should be repairing that but the factory.
No. I think the question is, if it breaks, can we fix it here?
Yes.
And the answer is yes, as long as the board is not damaged. As long as the printed circuit board is not damaged due to overcurrent, we can, if it's a component failure, we absolutely can fix that.
Next question, the warranty. Is it our standard warranty, Steve?
1 year standard warranty, parts and labor under a year, and that's the same with all our products. Again, I just want to ask, if you're typing a question, go ahead and hit the raise hand button just real quick. That'll let us know that a question's coming. Oh, here we go.
So the question is, if you had to design it again, what would you change? Well, I don't know. We just designed it, so.
I think the answer to that is customer feedback, and it'll be, we wouldn't change a thing. We'll change it on the next one when we have more information from customers and what the market needs.
You're welcome.
All right, looks like that's all the questions that we've got for this morning. I want to thank everybody for being here. I want to remind you to please send us feedback if you have any suggestions on how we can make these webinars better. And again, I want to thank you on behalf of myself, James, and the team here at Directed Energy. We really appreciate your time and look forward to speaking with you. Thanks.